Expectation of a continuous random variable is what we are going to see here. Please don't forget to subscribe to the channel. Now, for continuous random variable x with the PDF f of x, the expectation is given by px, which is defined as you get the interpret for all values of x, then you get the function here x, multiply it with the PDF for that random variable. As simple as that. So it's sometimes called the mean value of random variable x, sometimes denote it with mu as we saw in the expectation. And these are the properties, they are almost similar, but they are similar to those of the ones we saw in this grid. So if we have this result the same as this, if we have a constant, expression of a constant the same as a, if we have a function, expression of any given function, you just get that function multiplied with the PDF of that continuous random variable. Let us see how we go about it. So continuous random variable has a PDF distribution, a probability distribution below, given by this. I think now we are used to this. Find A of x. Now, find, don't want to say constant, but if a question doesn't tell you to find that constant, you need first get out that constant. So we first get this constant, so it means that now I should get the integral from 0 to 2. From 0 to 2, now this is our constant, k over 2x, then plus integral from 2 to 4. The PDF is k. Remember the x, also here the x, they also will be giving us 1. So here we have k over 4, x squared, and then we reduce the power by 1. That will be 2 divided by 2. 2 times 2, that's why we're getting a 4 from 0 to 2. Then plus this one, which I will get x from 2 to 4 equaling to 1. So if you substitute the, here we have k over 4 into now, and substitute the 2 squared minus 0 squared, then plus k into 4 minus 2 equaling to 1. So this will be 4 minus 0 is 4. Right by this we have k, then plus 2k equaling to 1. Implying that now the whole of this we have 3k equaling to 1. So our k is 5. So after getting that, we now write our PDF without that constant k. It's going to be now the integral from now k over 3. K over 3, and this is going to be now x over 6 from 0. Then this one is a third from 2, 4, then 0 as where. This is our PDF now. This one we have just substituted k. Remember we have k, then x over 2. Our k is a third times x over 2. That's why I'm getting the x over 6. So now, to get the mean, the expectation, so remember one, our e of x, we said it's the same as integral for all those values, for all x of x, then with our PDF dx. Now, what does it mean? It means that now we are going to integrate. First of all, we have to, this from this up to this, so we have now from 0 to 2, we get x times now our f of x, which is x over 6. This, then the x, then plus also from 2 to 4, we get x times the PDF. Remember, we get x times the PDF. So our PDF in this range is this. Then in this range is our third, the x. Then we just integrate this. Okay, this will give us now integral from 0 to 2. This will be x squared over 6. The x now plus, this will be from 2 to 4. This will be x over 3 dx, which we can happily integrate. When integrate this, I get x cubed, increase the power by 1 by 1 power, which will be 3. 3 times 6, which will be 18 from 0 to 2. Then plus, integrate this, you get x squared over 6. The other 2 multiply 6 to get 6 from 2 to 4. If you substitute our upper limits and lower limits, when you square here 2, you get 8 over 2 cubed is 8 over 18 minus 0. Then plus, for this one I get, when I substitute in here 4, I get 16 over 6. Then minus, when I substitute in 2, I get 4 over 6. Now, when you simplify that, the whole of it, so it's about here, we can simplify. I'll be having 8 over 18, then plus, this one is giving me 12 over, this will be 16 minus 4, that's 12, divided by 6, which is 2. And then we say this is 18, it will be 8 plus that 6, all over 18, which will give you 44 over 18, which will be 22 over 9. That will be our answer in that case. Then number 2, when you turn to e of x squared, the same idea, you get x squared, you multiply it with the PDF. So it will be now x squared, then times the PDF, dx, for all x. So now, we shall get now, remember we have 2, so now we will multiply here with the x, so I get x squared times the PDF, which is x over 6 dx from 0 to 2, then plus from 2 to 4. Now I'm getting x squared times the PDF here, which is a third dx. So that's how I'm doing in simple terms. You always get this time as the probability function in that. So this will be now, when I multiply there, I have integral from 0 to 2, x cubed, when I multiply there, over 6 dx, then plus from 2 to 4, x squared over 3 dx. And then I this, I get x over 24 from 0 to 2, then plus. And then I this, you get x cubed over 9 from 2 to 4. And then substitute, the answer I'm expecting you to get is going to be 62 over 9 over 9, and that will be our answer. So that's how we handle this one. Is representing now this idea. When you have any function, you just multiply with the PDF, then you do that. So that's it, members. I wish you